Many people use the term exponential, but what does it really mean? To give you a visualization of this, say if I were to take 30 linear steps, each step being a meter. 1, 2, 3, 4. After 30 steps, I would end up 30 meters away. But if I took 30 exponential steps, 2, 4, 8, 16, 32, I would end up 1 billion meters away. In other words, enough steps to go around the planet 26 times. I'd like to start, ladies and gentlemen, by introducing to you the brilliant Ray Kurzweil. He's an American author, inventor, futurist, and a director of engineering at Google. Bill Gates of Microsoft believes Ray Kurzweil is the best person he knows at predicting the future of artificial intelligence. Kurzweil doesn't just throw around random prophecies. He makes educated, calculated predictions based on solid, concrete evidence. And for this reason, 89 of the 108 predictions he made were entirely correct by the end of 2009. In the 1980s, Kurzweil extrapolated the performance of chess software to predict that computers would be the best human chess players by the end of the century. In May 1997, Garry Kasparov, chess world champion, was defeated by IBM's Deep Blue computer in a well-publicized chess tournament. Now, something that I've noticed quite often is the reaction that many people have when told about the incredible advances in technology that we will achieve in a mere 50 years. You know, disbelieving, doubtful, unconvinced, in fact, quite certain I've gone mental. Now, the reason behind this is because we instinctively don't see growth as being exponential. The way we think is defined by our traditional pre-programmed survival instincts. And so, for the need of survival, we have only ever needed to think of growth as being linear. If we eat 1 egg per day, in a month we'll eat 30 eggs. If we build 1 house per day, in 30 days we'll have 30 houses. The challenge here is accepting and understanding that our technology is advancing at an unprecedented rate. Ray Kurzweil says that the speed of exponential growth is itself also speeding up. What we need to do is move on from this linear mindset and learn to think in exponential terms in order to fully understand that, firstly, I am not crazy. And secondly, the level of progression that we will witness is going to be beyond astounding. Now, let's take a closer look at this term exponential. I'd like to explain it with the help of an analogy. Imagine there was a lake with lily pads. Now imagine that the number of lily pads on this lake doubles every day. If it takes 30 days for the entire lake to be covered in lily pads, how long would it take for half the lake to be covered? Now, most people would say, well, if it took 30 days to be fully covered, then it must take 15 days to be half covered. However, they would be wrong. This is a clear example of how we are pre-programmed to think linearly. A proper understanding of exponential growth allows us to realize that on the 29th day, the lake would be half filled, and on the 30th day, it would be fully filled. Such is the nature of exponential growth. So moving on, I'd like to briefly talk about all the incredible advances in technology that we will achieve in the near future. Within 2 decades, we will have a detailed understanding of how all the regions of the human brain work. The technology used in human brain scanning is exponentially improving, and we are now obtaining the tools sufficient to begin serious reverse engineering of the human brain. And once this happens, who knows what else is possible? Furthermore, by the end of this decade, we will have the necessary hardware to emulate human intelligence with supercomputers, and by the following decade, with personal computer-sized devices. And by the mid-2020s, we will have software models of human intelligence. By the end of the 2020s, with both the hardware and the software needed to fully emulate human intelligence, artificial intelligence will be indistinguishable from that of biological humans. Machines will then have the ability to combine traditional human intelligence strengths with the strengths of machine intelligence. And a major, major advantage that machine intelligence has is their ability to share their knowledge at extremely high speeds. Computers process and switch signals at close to the speed of light, in comparison to the very slow speed at which we humans share our knowledge, that is, through language. The speed ratio between machine intelligence to human intelligence is around 3 million to 1. Machines will then be able to download skills and knowledge from other machines, and eventually from humans. Take a moment to imagine this world that I'm talking about, because this is our future. This is what we are going to achieve. And yeah, right now, it may sound like crazy science fiction, but this is where we'll be in a mere 20 years. As technology is improving at exponential rates, they're increasing in performance and decreasing in size, while prices are dropping drastically. In 1968, you could buy one transistor for $1, but in 2002, you could purchase around 10 million transistors for that same dollar. One key example I'd like to elaborate on is DNA sequencing. In 1990, we began scanning the human genome. Critics claimed it would take thousands of years to complete given the speed at which the genome could be scanned. So, what happened? The project was completed in 15 years, ahead of schedule, with the first draft available in 2003. Exponential growth, ladies and gentlemen. The cost of DNA sequencing data has also come down from around $10 per base pair in 1990 to a couple of pennies in 2004, and is rapidly continuing to fall. Moreover, the amount of DNA sequencing data that we've collected is also exponentially improving. We sequenced and identified the SARS virus in 31 days, in comparison to the 15 years it took for the HIV virus. In fact, what was once a $10 million project can now be carried out if you have a spare 10K lying around. And all of this is possible through the exponential growth in technology. The degree of innovation that is occurring, even at this moment, as you are listening to this talk, is exceptionally staggering. We are truly in the midst of an explosion of technology. When scientists become a million times more intelligent and operate a million times faster, a single hour would result in a century of progress. And that is just at today's rate. We will transcend the limitations of our biology. Our non-biological intelligence will be trillions and trillions of times more powerful than unaided human intelligence. We'll begin to rethink our ideologies and structure our approaches. Some will be scared, some excited. Regardless, this will inevitably be